Hello everyone, my name is Ayushi Gupta and today we'll be talking about a machine learning technique. So first of all, we need to know what is machine learning. Machine learning is basically a branch of artificial intelligence and it is basically nowadays can be seen as a growing technology which enables our computers to learn automatically from the past data. It uses algorithms to determine and present complex relationships from data without making any strict assumptions about it. It is also been defined as the capability of a machine to imitate intelligent human behavior. Thus, it can be understood that it is trying to solve the complex problems, but in a way that how humans solve their problems. So today we'll be talking about one of the techniques of machine learning, that is the recurrent neural networks, and further we'll be talking in detail about the recurrent gated units. So moving on, we'll be talking about the neural networks. What are the neural networks and what are the issues with the traditional neural networks? So further, we'll be talking about how the recurrent neural networks came into picture. What is their definition? How do we understand the RNN? And further, what are the types of RNN and the applications used for RNN? Then further we can see an innovated technique further, that is the gated recurrent units. So we'll be understanding about it in detail. How does the human memory work? So how do we memorize things? We are all familiar with different songs, but how do we learn a song? Is it in a way like what is the 10th word of an XYZ song? How do we memorize a song? So we learn them in a sequence. It can also be said as a conditional memory. You can understand this also by a movie scene. How do you remember the movie scenes? Neural network with a memory works in the same way. Its output relies on the current input and the history information. Whereas in a traditional neural network, the output relies on the current input itself. On the left, we can see a basic layout of a neural network, which includes the input layer, multiple hidden layers, and the output. Neural networks. Machine learning has been segregated into five classes, one of which is the neural network-based learning. Their name and the structure are inspired by the human brain, mimicking the way that biological neurons signal to one another. They are also known as artificial neural networks and are comprised of node layers. Each node or artificial neuron connects to another and has an associated weight and threshold. But if the output of the individual node is above the specified threshold value, that node is activated, sending data to the next layer of the network. Otherwise, no data is passed along to the next layer of the network. Below, an example has been provided where we can see the input are the image pixels of two different breeds of dog, and the network helps us to give the output about the two dog breeds. It helps us identify the different breeds of the dog. But there are some issues with the traditional neural networks. One of which is they cannot handle sequential data. As we learned earlier that sequential data requires some of the previous informations also, but the traditional neural networks are based only on the current input. It does not have any memory about the past and does not have any future scope. So these are the three problems listed for the traditional neural networks. So the above issues can be tackled by a network with memory, that is the recurrent neural network. Recurrent neural network is also a type of artificial neural network, which basically takes the output of the previous step and feed as the input of the current step. Unlike the traditional neural network, all the new outputs in the network are dependent to the previously generated output. It is mainly used in the cases where we need to remember the previous generated data, and it is hidden or memorized in the hidden layer of RNN. And we can understand that the importance of RNN is that it uses the prior understanding or the prior outputs to get the understanding of the new instance. Thus, the machine is able to think more likely as a human. Thus, due to this framework, The RNN can handle the sequential data. It considers the current input and also the previously received inputs, and also can memorize the previous inputs due to its internal memory, that is the hidden layers. To understand the mathematical foundation of an RNN, you can look into the network presented in the slide, where X is the input layer and H is the hidden layer and Y is the output layer. Whereas A, B, C are the parameters associated to these node layers. We can understand from the expansion shown that our new state is a function of the previous output as well as the new output, and a more clear understanding can be seen through the mathematical formula presented on the right hand side below. Types of RNN. RNN can be mainly divided into four types. One-to-one allows a single input and a single output. Basically, its application can be found in the image classification. The second one is one-to-many, which has a fixed input size and gives a sequence of data outputs. Its application can be found in human generation, in sorry, in music generation and image. Many to one. It basically has a sequence of inputs to display a fixed output. Sentiment analysis is a common example of this type of RNN. Then many to many. Many to many has been subdivided into two parts, that is the equal unit size and the unequal unit size. The equal unit size has the number of both input and output units is the same. A common application can be found in name entity recognition. Then the unequal unit size. In this case, inputs and outputs have different number of units. Its application can be found in machine translation. Applications of RNN. So nowadays, whenever we need to know about something, we reach out to Google for the same. But do you know how does the Google's autocomplete feature predicts the rest of the words a user is typing? So Google forms a collection of large volumes of most frequently occurring consecutive words, which is further fed to a recurrent neural network, which helps to analyze the data by finding the sequence of words occurring frequently and builds a model to predict the next word in the sentence. So whenever, for example, you go to the Google search to type what is the best food to eat in Lhasa. So the Google automatically from its previous information generates the rest of the word, that is Vegas. That is it auto completes the search. Other applications of RNN includes natural language processing, image captioning, time series prediction, and machine translation. These simple RNNs undergo difficulty to capture long-term dependencies because the gradients tend to either vanish or explode with the long sequences. Two particular models, that are the long short-term memory and the gated recurrent units, have been proposed to solve the vanishing and exploding gradient problems which were being seen in the simple RNNs. What are gated recurrent units? Recurrent units are a type of RNN that use gating mechanisms to control the flow of information through the network. They were introduced as an improvement over the original RNNs. GRU basically have two gates, that is the update gate and the reset gate. Further, we have seen that GRU have shown to be effective in a variety of tasks such as language modeling, speech recognition, and machine translation. They are also computationally efficient compared to other types of RNN such as LSTM. To get a more clear understanding about gated recurrent units, you can look into this example where a sentence have been given where that is Dhaval eats samosa almost every day. It shouldn't be hard to guess that his favorite cuisine is Indian. Here we are trying to predict the output as Indian from the previously generated information that Dhaval eats samosa. So the input that needs to be memorized to predict the output is samosa. In a traditional RNN, since it is not able to work in long-term dependencies, it won't be able to memorize the samosa. It won't be able to memorize the previously generated information, that is the samosa, and would only be able to work in the current state, that is cuisine in. Whereas a GRU would able to memorize the previously generated data, and it would be easier for it to predict the output as Indian. The basic difference between the two proposed models, that is the LSTM and the GRU, is that LSTM has two sets, that is the long-term memory and the short-term memory, whereas in the GRU these two memories have been combined to make a single state, that is the long and short-term memory. As we have seen earlier, that the gated recurrent units work on the gated mechanisms, and it consists of two gates, that is the update gate and the reset gate. Gate is basically how much of the past memory to retain, and reset gate talks about that how much of the past memory to forget. Like if we extend our example further by adding that the Dhaval's brother Bhavin, however, is a lover of pasta and cheese. That means Bhavin's favorite cuisine is Italian. So to predict the output as Italian, the network further needs to memorize pasta and cheese. So specific to the example, we can see on the left, this is a GRU cell where we understand how does the reset gate work. So to retain the memory of the pasta, the reset gate needs to forget the memory of samosa. So here the reset gate uses the hidden layer H and the input layer X and applies a sigmoid function on it to get the formula which is mentioned below. Further, in an update gate, it needs to retain the memory of pasta, so it uses the hidden layer H and the input, that is cheese, to and applies a sigmoid function on that. You can see in both the gates the mathematical formulas are the same, but the weights assigned are different. Here we can see the weights are WR and UR, whereas in an update gate the weights are WZ and UZ. So we use the update gate values, the reset gate values, the input layer and the hidden layer to predict the further hidden layers and the output. On the screen we can see how a GRU cell finally looks like. It is understood that the GRU combines the long-term and the short-term memory into one state, and it can be seen that it is lightweight than a natural LSTM. Here the multiplication function is basically the Hadamard product, which is the multiplication of two matrices. All these functions that we can see in the cell are applied on the different layers to finally get the output. Mathematical understanding. So to understand the GRU more, here we can see the mathematical understanding of a GRU. On the left hand side is the basic formula that is used for the output of RNN, whereas on the right hand side are the gated recurrent units formula. Difference between LSTM and GRU can be seen also through this representation, where we can see an LSTM consists of mainly three gates, that is the forget gate, input gate and output gate, whereas the GRU is more lightweight, is much lighter than the LSTM, which consists of the reset gate and update gate only. Further, these are the major three differences which can be identified in the LSTM and the GRU, that it consists of three gates whereas GRU consists of two gates. LSTM is more accurate in a longer sequence but is less efficient, whereas GRU is efficient commutation wise, and it's getting more popular nowadays. The LSTM was invented in 1995 to 1997, whereas GRU was invented in 2014 itself. So this was a brief about the recurrent neural networks and the gated recurrent units. I hope you understood a bit of it. Thank you and have a nice day.